Hello everyone and welcome to a new course which is on groundwater engineering, and in this course we will have 60 lectures of about 30 minutes each, and in this course we are going to discuss starting from what is exactly water, then groundwater, what is surface water, how it is groundwater is stored in the subsurface conditions, where to find water, how to exploit water, how to recharge the groundwater regime, and also we will be discussing about pumping test, modeling and other related environmental issue with this. So, this is I am sure it is going to be very interesting, it is exciting for me. So, let us start. First is as we know that very basic thing I am going to discuss here, but it is important because later on when we will discuss the chemical quality of water, these things will come. So, as you know that water is an inorganic substance which is also transparent. If pure water should be transparent, tasteless, odorless and nearly colorless. But sometimes people say that it is not purely colorless, the blue color will come, that we will see that why it comes when a large volume of water is stored on surface. And so, this inorganic transparent, tasteless, colorless, odorless substance composed of chemical elements which we know hydrogen and oxygen, and exist in gas in all three forms, that is gaseous, liquid and solid state. So, this substance is on the earth is very unique. Now, this is one of the most plentiful and essential compounds of life or essential part of life. Why I am putting this plentiful with question mark? Because though nature has given us about 70% water on the earth, but which water we can use, that means fresh water for drinking and irrigation, that is getting limited because of population, over exploitation and other things. So, in this course we will be also discussing, that is why it is not truly a plentiful, the usable water. And the main constituents of earth's hydrosphere, that is water. And if we start seeing the how this structure of chemical formula, which is of course H2O2, and then meaning H2O, and meaning that each of its molecules contains one oxygen and two hydrogen atoms and connected by covalent bonds, which is also shown here. And in between these two hydrogen element bonds, these molecules, you are having a angle of 105.45. So, these two hydrogen atoms are attached to one oxygen atom at an angle of 105.25 degree. This is important because when the state changes of water, then these angles and other things might change. As we know that water also exists, as now a lot of studies which are coming from other planets or like a satellite of Earth, Moon, that water also exists on other planets and moons, and maybe both within and beyond the solar system. This is what now new discoveries are there. But the water on these surfaces like Moon or Mars, which we know more, is not like on earth, because their atmosphere is very thin, they do not have such storage of water and other things. So, either water is stored in either water is available in form of molecules along with some minerals, or only on the polar regions of these bodies like Mars or moons. So, water is there and not only on the earth, but other parts of the solar system. And a small quantity of water appears, as we know, colorless, but as just mentioned that water actually has an intrinsic blue color, and this happens because of a slight absorption of light at the red wavelength. So, if you understand the electromagnetic spectrum, then you know that if any light is absorbed, then that is not there, but the light which get reflected, that becomes the color. So, in this case red wavelength light is absorbed by the water, and therefore, the blue light is get highlighted, and water bodies sometimes looks blue. But if you take in a small quantity, then water is colorless. and a pure water should also be odorless. So, life is believed to have originated in aqueous solutions of world's oceans, and living organisms depend on aqueous solutions such as blood and digestive juices or biological processes. This is what the understanding currently we are having and about the role of water towards the development of life. Now, there are a lot of discussions nowadays about because India is having its own satellites for moon and trying to land successfully on moon surface as well as Mangalyaan. So, research is going on Mangalyaan. They do not have so much water. So, that is why life expectancy there seems to be currently very poor. Water is essential for life, as we know. So, it is vital for all known forms of life, even though it provides no calories or organic nutrients. That is the amazing part of it, but it is essential. So, that is very, very important. And indeed, the versatility of water as a solvent is essential for living organisms. So, every living organisms, every life on the earth or other parts requires always water. An essential fluid of all known living organisms in which it acts as a solvent. Solvent, water is the one of the most cheapest solvent available on the earth. It dissolves so many things there. And water is the name of liquid state. However, when we go for other state of water, then things changes depending on the conditions of temperature and pressure. And all these even in case of ultimately our aim is to learn about groundwater. But to recharge the groundwater regime, sometimes we have to store the water on surface, and there this temperature and pressure also plays very important role. How much evaporation will occur, that is why it is necessary to know at this stage. And water forms precipitation in the form of rain, aerosols in the form of fog. And this is another important thing, that when fog occurred, as we know that the fog is having a nuclei, and that nuclei is by aerosols, might be dust particles, might be gas particles, and around that nuclei then water is trapped, and that is overall that makes the fog. So, fog is also having water. Fog is nothing but the low stratus clouds basically, but it is having more pollutants as compared to the clouds which are at a higher height. So, we know that cloud consists of suspended droplets of water, sometimes ice, in solid state also. Sometimes we get the hailstorms and other things. So, that is the solid form of precipitation. And finally, we divide the crystalline ice may precipitate in form of snow also. So, water is available on the surface of the earth. If we start talking only suppose on surface of the earth, we get the rain in liquid form, we get in form of crystalline form snow, very common in many countries including in Himalayan terrain in India, and also hailstorms we may get anywhere part of the world, especially in many parts in India also. And in gaseous state of water is in form of steam, water vapor, or in other water vapor we also say humidity. So, like in monsoon season when temperature is high and it is lot of moisture is there in the atmosphere. So, that creates the water vapor, and that becomes very uncomfortable for humans because of high humidity and high temperature. The overall effect of this combination is more challenging for humans to live comfortably in these conditions when high humidity and high temperature is there. Anyway, I said in the beginning that there is plenty of water, but what water we can use? The water which we can use should be drinkable or for irrigation purposes. So, if we see this distribution of water overall on the surface of the earth, or the left one, the total global water. So, we are 96.5% is the ocean water. So, directly it cannot be used, though after processing it can be made equal to near to fresh water, and then we can consume it. And on this only the fresh water which is available in form of snow, ice, glaciers and streams, springs is only 2.5% of the total global water. So, very tiny amount of fresh water is available to us for consumption. Now, when we see within this fresh water where it is distributed, this 2.5%, then we see that groundwater is where we are concerned more in this course, is about 30%. And the large amount of fresh water is stored in form of glaciers and ice. So, when there is a melting season of snow and ice and from the glaciers or high altitude regions, that too get converted into liquid form, and finally it may, some part of that may come as a contribution to groundwater. But nonetheless, overall an average is about 30% of 2.5%. So, you guess that how small quantity of water is available for our as fresh water. And then if we take like surface water or other fresh water, then that is only 1.2%, and that too is stored in form of ground ice, permafrost, which is not much common in India except for some Himalayan regions. Then some parts 20.9, roughly 21% in form of lakes, and some part is in atmosphere also. So, what we are dealing is about I would say that roughly 1% of total global water which is available on the earth, less than 1% is groundwater. But it is important because this provides the sustainability of life, especially in those seasons or those months when we do not have much fresh water left. So, most of the exploitation then done from the groundwater. So, groundwater is such an important thing for life also, especially in the tropical or subtropical regions where you do not have much other resources left. So, water, as I have just completed, that water covers 71% of the earth's surface, and that is also mostly in sea and oceans, and only a tiny small portion of water occurs as groundwater, which is just 1.7%, and rest water in form of glaciers, and a large part is located, this water, in form of ice and glaciers in Antarctica or Greenland. So, directly we cannot use that as a fresh water anyway. Now, when we say fresh water, this is fresh water on the earth, which much more is stored in the ground than available in rivers and lakes. So, this is what we most of the time exploiting, and more than 84,100 square kilometer of fresh water is stored in the earth, most within 1/2 kilometer of the surface. So, we can think that where, so it seems that the figure looks very high, but it is really from consumption point of view, from available global water point of view, it is not very high. But most fresh water is stored in the form of water found in glaciers and ice caps of this quantity, and mainly in polar regions and greenlands. That is not directly we can use as fresh water, at least currently. Future we might be thinking in that direction. So, water, now we can define basically what is exactly groundwater is, that water present beneath earth's surface, ground surface, either in form in rocks or soil pore spaces, and also might be in hard rock terrain conditions, in fractures of rock, which we called as groundwater, or some people also called as subsurface water, because it is below surface of the earth. So, the water which is present beneath the earth's surface in rocks, soils, fractures, and this is what we call as subsurface water or groundwater. As we can see here in this schematic, that on the surface we have, land surface is shown, the green part, then you are having a unsaturated zone, there though moisture is there, but it is not saturated with water, and then you are having a zone which is called saturated zone, and that region we would say is having a groundwater. That does not mean that everywhere there groundwater. Groundwater is stored in spaces, and these spaces can be pore spaces, fractures of the rocks, or if there are sedimentary rocks, then it might be in those formations where gaps are there depending on porosity and permeability. So, but nonetheless we say saturated. So, that means these rocks are saturated with water, and most of the water which is exploited from groundwater is generally tried from these saturated zone. Now, surface water is also shown here because it plays very important role, that whether the groundwater regime is recharging a stream or vice versa. So, that plays in some streams recharges groundwater regime, whereas many streams gets water from groundwater in form of springs. So, that we will be also seeing. So, fractures, gravels, if sedimentary rocks or loose sediments are there, and then it may be stored within the spaces which is available in the grains of different sediments, and if rocks are hard, but they are fractured, weathered zones are there, then water may be stored there also. But the volume of water which can be exploited from such these bottom two scenarios is not much, and that you can assume that why it is so precious. Now, when we say about this water, groundwater, then in the middle part which you can see, which I have already said, zone of saturation. So, if we start from top, say, then you are having a surface might be having vegetation, and that is what the moisture part in the soil, which we call the soil water. Now, everywhere on the surface of the earth, it is not necessary that you would have soil. In a typical hard rock terrain, you may not have even soil cover at all, just simple rocks are there. So, you do not get this soil water at all, intermediate water you may not get, capillary action or capillary water may not be, or capillary zone may not be there, only rocks are there, and in fracture or weather zone you may have some water, and these are may not be again saturated zone. And then finally, you are having other part which is having fully saturated zone also. So, if we see on the right side the moisture profile, as elevation changes, the moisture profile or moisture water content changes also. So, from top it is less and in a dry portion, but as we move downward, generally not necessarily in all geologic conditions, not in natural conditions, but normally this is what happens. Then when we go deeper, we get the water. Nowadays, a lot of tendency is there among people that they think that if they go for a deeper tube well, they will get more water. Not necessarily. It depends where they are striking or finding saturation zone, and whether their saturation zone is getting recharged through rainwater or some other sources. Then only their tube well may give water round the clock or round the year. But if you are not, if you think just going deep will always be give me the water or groundwater, not necessarily. So, it is in a very special conditions you may get water at a deep stage. Otherwise, as you go deeper and deeper, the rocks becomes harder and harder, and these fractures and weathering also very little, and therefore, the storage capacity of some rocks reduces like anything. So, it is not necessary that deeper boreholes will give more water. So, groundwater occurs, as we have just said, in the zone of saturation in which all interconnected voids are filled with water, that is under hydrostatic pressure. Now, here it is written all interconnected voids, but in all geologic conditions in rocks, it is not necessary that all voids will be interconnected. So, what I am trying to say, very briefly I am bringing two terms, one is porosity and permeability. So, if there are lot of pore spaces, then porosity may be high, but if they are these pore spaces or voids are not interconnected, then permeability, that is flow of water from one place to another, may not be good. So, groundwater can be divided as we have just seen on the right figure, that groundwater, or also people say pharetic zone or pharetic water, vadose zone, vadose water, and finally the internal water. Some internal water might be there in form of structure or molecules and other things. So, groundwater, now there is another term, groundwater table be used. So, groundwater table is between the upper surface of the zone of saturation, the top part of zone of saturation, and bottom surface of the zone of aeration. So, there you find that what surface which is basically, I would say, imaginary surface, because we can't see inside the earth that table. So, that surface we called as water table. It is also shown here as a water table, which can be seen here, that water table, groundwater table is there. So, this is upper part of the groundwater surface and lower part. So, this part we always say this is, or from top basically it is mentioned. So, from zone of saturation, above the zone of saturation, and bottom part of zone of aeration. So, this generally water table information is measured from the top, and by lowering a tape in the tube well or other things. So, that becomes my water level. When we bring the altitude information in this, then it becomes water table information. Those things we will see later in this course also in detail. Now, vadose zone, which we have classified earlier in 3 parts. So, one of the section is the vadose zone, which is called intermediate water, and which includes water held in intrinsic of capillary dimensions and percolating from surface to the zone of saturation. And this keep happening in case of if surface on surface you are having impoundment of water or surface storage of water. Then slowly because of these processes which are very slow, but still they go, and like we know that before monsoon in Indian conditions, before monsoon this water table goes down because people keep exploiting the water. But in monsoon season, or if you measure just after the post monsoon, then what you would find, this water table might have reached up. So, that means this process has taken place and it has recharged the groundwater regime, and therefore, the water table has gone up. So, this is important also, that what important role our monsoon system is playing towards the recharging groundwater regime, and that water, if exploited scientifically, then that water may be available for round the year. So, according to origin and source, groundwater can also be classified into different types of water. One type is connate water, water which is entrapped in the interstices of sedimentary rocks at the time of its deposition, and also called fossil water and often saline water. Those who do not have the background of earth sciences or geology, for them let me, I am sure you must have studied in your 10 or 10 plus 2 classes that they basically rocks are of 3 types: sedimentary, igneous and metamorphic. So, it is always presumed that more water, more groundwater would be available in case of sedimentary rocks. But water can also be available or is available sometimes depending on the conditions in igneous rocks as well as metamorphic rocks. But the sedimentary rocks are most favorable places where you can get water easily, and especially like sandstone or other types, similar types of rocks. So, connate water, which is entrapped in the intrinsics of sedimentary rocks at the time of its deposition, also called fossil water and often saline. So, if you trap that water, if you exploit that water, though it is fossil water, it might be saline also, because it was stored when these sedimentary rocks were formed. Another water is called meteoritic water, which is derived from atmospheric precipitation and in circulation. And third one is juvenile water or magmatic water derived from the interior of the earth, very in that sense, So, that is why this term juvenile is used. And then volcanic water, which is driving its heat and chemical activities from volcanic sources of volcanism. So, this different type of water, but mainly our focus is in groundwater, whatever the origin, if it is fresh, if it is drinkable, we should focus and use that water. So, in Indian scenario, if we look that India experiences an average of precipitation of 1170 millimeter per year. This is average for the entire country, and about 4,000 cubic kilometer of rain annually occurring. This is, if you think, this is a quite large quantity of water which is falling over India, and about 1720 cubic meter of fresh water per person every year may be available, can become available. So, India accounts for about 80% of world population and about 4% of world water resources, and there is the problem in India. That is why studying of groundwater is very important, groundwater engineering, and that includes the where to find water, how to exploit water, how to construct proper groundwater belts and so on, and where to recharge the groundwater. So, this from 18% to 4% population from world reference 18%, and the water available from world reference is just 4%. So, this gap can be filled. I am saying this gap can be filled if we do better management of water and especially groundwater. So, this is annual distribution. As you can see, the northeast India get maximum rain, then eastern part, and of course, the western part, as we know, Rajasthan, some parts of Gujarat, they get less rain. Otherwise, quite in my opinion, quite sufficient rain occurring all over the India. If we store water, then this gap can be also filled. Nearly 80% of India experiences rain of about 750 millimeter per year. So, average, as we have seen, that 1170, because in some places they are getting more, but in that 80% of India experiences rains of 750 millimeter per year, which if we store this water properly, if we recharge groundwater regime even with this amount of water of 80% area, lot of water problems can be solved. However, this rain is not uniform in time or geography. So, we know that this is keep changing, interannually there are changes, and decade wise or century wise there are changes. So, that is also that is creating some problems, but the solution is that whatever the water is falling as a in form of rain or in precipitation, if we can store even 1 or 2% of that water in groundwater regime, this problem can be solved. But discussion on this aspect we will have in really a good detail also. So, most of the rain occurs during monsoon seasons. We know that there are two monsoons in India prominent. One is of course the major one is the summer monsoon, another one we are also having in the winter months, and from different directions the monsoon is progressing, and it brings moisture and basically ultimately in form of rain. And the other melting other rain or that occurs, the melting of snow over Himalayas was winter season, feeds the northern rivers to varying degree. Because we know that during winter time you are having snow and glaciers are also there, depending on the temperature conditions and other things, seasonal things or weather wise, the snow also melts, and that brings the water into the rivers of India. Various rivers of northern India are fed by snow and glaciers. So, they are very important source of fresh water to us. Also some water goes of these rivers goes as a groundwater for groundwater recharge as well. Whereas southern rivers or rivers of South India experience more flow variability over the year, because they are not fed by a glacier or snow. For Himalayan basin, this leads to flooding in some months of water and scarcity in others, as we can see here also that their rivers are shown, and where these are the places, the dots we are showing, the gauging stations and other things are there. Despite extensive river system which you can see on right figure, and the safe clean drinking water as well as irrigation water supplies for sustainable agriculture are in shortage across India. and that reason I have told you 18% population, only 4% of water available. So, currently country harnessed a small fraction of its available and recoverable water surface water sources, because surface water and groundwater, these are the connected waters. One cannot look in complete isolation the groundwater or surface water. So, whatever the situation is, we can harness more this water and can make comfortable on that front. So, India harnesses about 761 cubic kilometer, that is 20% of its water resources, part of which comes from unsustainable use of water, and that is about 688 cubic kilometer which goes to irrigation, 56 cubic kilometer goes to municipal and drinking water applications, and 17% or 17 cubic kilometer goes to industry. That amount of water is there. In summary, what I can say here in this particular discussion is the majority of India's water problem are those relating to groundwater, because in other seasons when monsoon rain are not there, surface water are going dry, then we start depending on groundwater. So, majority of India's water problems are related with groundwater, but there are advantages with groundwater which we will be also discussing in this course. So, this is because we are largest user of groundwater in the world and highly dependent on it. That is why we face more problems, and just over 260 cubic kilometer per year our country uses 25% of groundwater extracted globally, and ahead of many countries like USA and China. And finally, since 70% of water supply in agriculture today is groundwater, and it will remain the lifeline of India's water supplies for the year to come. So, if we can make less dependency of agriculture on groundwater, the more water would be available for drinking and other purposes. But how to do it, and what are the solutions through groundwater recharge or storage water on the surface, those are the aspects which we will be discussing in next 59 lectures. So, thank you very much for time being. See you in the next discussion. Bye bye.